Keeper 4.2, interval of convergence. All right, so you have two general forms of your power series. You have one that's centered at 0 and one that's centered at A. So the basic form of them are pretty much the same. The only difference is the one that's centered at A, or some number A, it has the x minus A in it versus just x when it's centered at 0. All right, so you have three possibilities when finding the radius and the interval of convergence. All right, so your first possibility is that when you do the ratio test, because that's the test we generally use to find the interval, when you do the ratio test, you get infinity out. If you get infinity out, that tells us that the summation diverges because infinity is greater than 1. And so if the series diverges, your radius is going to be 0, and the interval is going to be whatever your A value is, whatever your A, or in this case your C value, whatever that is, whatever your center is, that's going to be your interval. And that's because it's going to diverge everywhere except for where your function equals 0, and your function is going to equal 0 at your center. All right, your possibility number 2 is that when you run the ratio test, you get a number less than 1. So like you get 0, which is less than 1. And in that case, it converges absolutely. And so if it converges absolutely, it converges everywhere, which means that our radius is going to be infinity, and our interval is going to go from negative infinity to infinity. All right, then your last possibility is that when you do the ratio test, you get some function in terms of x. In that case, you would have to set up an inequality to figure out what x has to be between. And then once you set up that inequality, you have to check your endpoints of that inequality to determine if those endpoints converge or diverge. Basically, in possibility 3, it says that everything inside of those boundary points or those endpoints converge, but it does not say what the endpoints actually do, so you always have to check those. All right, so example 1, it says determine the radius of convergence and the interval of convergence for the power series. And so the first thing I'm going to do is I'm going to start by using the ratio test. And so if you remember the ratio test, I can drop the -1 to the n since it's an absolute value test. And then I'm going to change everything to n plus 1. So I have n plus 1, x plus 3 to the n plus 1 over 4n plus 1. And then I'm going to times that by the reciprocal of the original. So 4 to the n times x plus 3 to the n. All right, so once I cancel out everything that can be canceled out, I'm left with n plus 1 times x plus 3 over 4n. And when I take the limit of that, since the top and the bottom is both has the same degree, they're both n, I'm left with the coefficient, which would be x plus 3 over 4. All right, so then I know that x plus 3 over 4 has to be between -1 and 1, just like we did with our geoseries. So because it has to be between -1 and 1, I can multiply both sides by 4, and then I can subtract 3. In other words, I know my interval is going to go between -7 and 1. At this point, I can also see that my radius of convergence is going to be 4, because the distance between -7 and 1 is 8. 8 divided by 2 would be 4. All right, now again, I know my interval is going between -7 and 1. However, I don't know if -7 and 1 needs to be included or not. I don't know if they're valid numbers for the interval. So I have to check each one of those. I have to check -7 and I have to check 1. All right, so my check for -7, I'm going to plug -7 back into my function, my original function, and then I'm going to simplify. So I get -1 to the n times n over 4 to the n times -7 plus 3 to the n. Well, that's the same thing as -1 to the n times n over 4n times -4 to the n. Now, if you simplify this all the way out, the 4n and the -4n are going to cancel. That -1 is also going to go away because of the -1 to the n. So basically, I'm going to be left with the sum as n goes from 1 to infinity of n. Well, I know that this sum is going to diverge, and I know it diverges by the divergence test because the limit as n approaches infinity of n equals infinity, which does not equal 0. So -7 is not going to be included in my interval because it diverges. All right, now I have to check x equals 1. So I plug 1 into my original function, and then I simplify that, and I get -1 to the n times n over 4n times 4n, or 4 to the n. Those 4 to the n's are going to cancel out, and it's going to leave me -1 to the n times n. Now again, I know that this series, or this sum that I'm working with now, is also going to diverge, because I know that the limit as n goes to infinity of -1 to the n times n doesn't exist. I know it oscillates. And so because it doesn't exist, it does not equal 0, and that tells me that it diverges by the divergence test. So again, 1 is not included in my interval. All right, so final answer, my interval of convergence is going to be -7 to 1. Make sure you understand that I'm using less than signs because I'm not including it, or I could write it in parentheses because I'm not including -7 and 1 by our check. And then our radius, we already figured out that our radius of convergence is r equals 4. All right, so example 2, we're going to work it the same exact way. This time we have the sum as n goes from 0 to infinity of n factorial times 2x plus 1 to the n. I'm going to start with that ratio test. And so my ratio test, I'm going to have n plus 1 factorial times 2x plus 1 to the n plus 1 over the reciprocal of my original, which would be 2 factorial times 2x plus 1 to the n. I'm going to cancel out everything I possibly can cancel out, and I'm left with n plus 1 times 2x plus 1. This limit equals infinity, and infinity we know is greater than 1. So that tells us that this series diverges by the ratio test. Now remember, it's going to diverge everywhere except for where this function equals 0. And so our function equals 0 at -1/2. If I took my 2x plus 1 and set equal to 0, I would get -1/2. So I know my radius of convergence is 0, and my interval of convergence is a single number, so I write it in curly brackets of -1/2. All right, here's my example 3, which is going to be my last case. Again, I could use the ratio test, but I think this time it would be a little bit easier to use the root test. The root test is just as good because it also shows absolute and convergence if it works. And so using my root test, I'm going to take my function and do the nth root of it, or raise it to the 1 over n. And so then I have the limit as n approaches infinity of x minus 6 over n. When I take that limit, I get 0. 0 is less than 1. So by the root test, I know that this thing converges absolutely. All right, so because it converges absolutely, my radius is going to be infinity, and my interval of convergence is going to go from -infinity to infinity.